Hi, everybody, and welcome back to my channel, Numbers with Nora. This is a math tutoring channel that helps you with all your math needs, wants, and help, homework, and etc., etc. For this video, I'm going to be doing geometry, chapter 10. I already did a video on lesson 10.5 Trig and Area, but this one is not going to be explaining it. This is more going to be just a bunch of practice problems, okay? The book I'm going to be using for this video is actually going to be Geometry Common Core. All right. So if you are following along in the same textbook or want to follow along with me, then go ahead and click on the description link and it will send you to the problems that we're doing today. But some of these problems might be in your other geometry book as well. Okay. So let's get to it. So again, this is going to be on 10-5, using trig to find the areas of regular polygons. If you go and look at my first video, like I said, that's going to be more explaining 10-5. So watch that before we jump into the practice. Okay. But it's always good to sit there and have your trig ratio sheet next to you so you know which trig ratio you're going to use on each problem. All right. So for this one, I'm just going to go ahead and choose like random problems. Okay. And if you want me to do a specific one, just put it in the comments. So let's do 6. Let's do 6, 10, 7, and 11. That sounds random. Those seem like good ones. Okay, so let's start out with 6. All right, so this one we have to find the area of a regular octagon with side length of 6. So for this one, I'm not going to draw out the whole octagon because remember, we really just want our right triangle, okay? That's created when we make a triangle in that octagon, right? So basically what we're trying to do is find the area. How we find the area of a triangle is basically 1/2 base times height. But again, in my last video, my base is just basically going to be my perimeter, right? And my height is going to be my apothem. And I have the definition of apothem in my other video, okay? So first, let's go ahead and find our base, which is our perimeter. They already give us that our side length is 6, all right? So with our perimeter, we're just adding up all of our sides, right? So I'll just put P right here. So octagon is 8 sides. I'm going to have 8 times 6. This is the same thing as just adding 6 8 times. Right. And that's going to give us 48. So that was easy to find our perimeter or our base for this one. All right. So this is what we're going to sit there and plug into our formula up there for our area. Next, I want to go ahead and find my height or my apothem. I'll just put A for apothem. Okay. So remember, our apothem is like this part right here. I always like to annotate my triangles so you don't forget what's going on. Remember, our height is the side that's right across from our 90-degree angle. This is going to be the angle that we're going to find. And the angle that we have or that we're going to find is always going to be my opposite. Okay. My side is always opposite from the angle that we're going to find. And then the remaining side is just going to be your adjacent. And usually your adjacent is going to be your height or your apothem that we're going to find. Okay. To annotate this, we know this side if we had to know it. Remember our whole side length, because that would be a whole side of our octagon. We're only finding half of that side of that octagon. So we want half of 6, okay, will be that side of the triangle that we're dealing with. All right. So half of 6, that's going to be 3. That's 6 divided by 2. Just annotate that. That's 3. All right. And then remember how we find this little angle up here. This was in my previous video. But basically, all you sit there and do to find this angle is you do 360 divided by the number of sides we have in our regular polygon. And this one, it's going to be 8. Okay. After we sit there and do that, that's going to give me my whole angle, which is going to be 45. But we don't stop there because I'm not looking at my whole angle of this whole other triangle right here. I wanted to turn it into a 90-degree triangle, which you will see better pictures in the other video that I did. So I want only half of this. I don't want the dotted part. I only want half of that. So I divide this by 2. Okay. So I only want that little bitty angle right there. I'm running out of room, sorry. So that little bitty angle, when you divide 45 by 2, you're going to get 22.5. Okay. And that's going to be the angle that we're going to use when we sit there and do our trig. Okay. So now to sit there and find our apothem, we know we have to sit there and find our trig. I sit there and know that I have my opposite side. My op is equal to 3. Okay. But I don't have my adjacent, and I need to find my adjacent to find my apothem. So that's when I sit there and look up at my trig ratios, and I want to sit there and see which one deals with op and adjacent. Okay. Looks like our tan deals with op and adjacent, right? So then I'm going to go with tan. So I'm going to do tan, and it's going to be of my angle that we just found, right? So tan of 22.5, tan of 22.5 equals my op over my hype, okay? My op is going to be 3. And then, sorry, I said hype. My adjacent, I don't know what that is. That's what I'm trying to find. I'm just going to mark that as X, okay? Now I just use regular algebra to sit there and solve this, okay? And I'll do every step just for those who aren't that strong with algebra. If you are stronger with algebra, you can fast forward this part of the video, okay? So to sit there and get my X isolated, I multiply both sides by X. When I sit there and multiply both sides by X, okay, I multiply that side by X. These will cancel out. Then I get X tan of 22.5 equals 3. And then I can treat that trig function just like its own kind of variable, or like its own kind of number, you know. So like I can divide everything, because my key is I'm trying to get X all by itself. I divide everything by tan of 22.5. See what I mean? I kind of look at them as like their own numbers, because it kind of is, you know. All right, divide both sides by tan. Okay, 22.5. 2.5. Sorry, it's taking me a while to write that. Boop. And then you would just cross these out, and your X would be all by yourself. And then you have X equals 3 over tan, 22.5. All right. And that's going to be my apothem. Now that I have my apothem and I have my parameter, I can go ahead and plug it into this area formula that we have right here. I'm going to give you a hint for your test that you're taking in class. Always write out everything before you plug anything into a calculator. So that way your teacher can see how you set it up. So if you do have a calculator error, most likely she won't take off that many points. Okay. So I have A equals, that 1/2 is part of my formula. And then times my parameter. So 48. 48. And then, like I said, I'm going to write out my whole trig function right here, because just in case I make a calculator error, I want my teacher to know that I did everything else right. Over tan. And then 22.5. Okay. Boop. So that is our answer, but like now I'm going to show you the calculator work for it, okay? Now let's do the calculator work and see what actual area we get. Okie dokie. Yeah, that's what I wanted. Just a second. So my thing doesn't go on. Okay, so let me pull up the calculator so we can go ahead and do the calculator work. Let me clear this. That's for my past one. So I'm going to go ahead and put all this in the calculator. It's kind of hard for me to use this computer calculator. Usually if you use a scientific one, it's a lot easier, but let's go for it. So I like to put parentheses in so the calculator understands what I want to do first. But since most of this is multiplication, we don't really have to do that. So 1/2, 0.5 times 48 times, now here gets the tricky part. I'm going to do 3 divided by, and then I put in parentheses, my 22.5 tan. Okay. And then equals. Perfect. And if you have to plug it into your your calculator differently, that's okay. All right. And then put down in the comments if you have any problems plugging this into your calculator, and I can probably make another video about how to work your calculator. All right. So the answer to this one is going to be 100, but I'm going to round it 174 cm squared. Okay. 174 cm squared is our answer. All right. And just so you believe me, I'm going to sit there and go and look this up on the internet. I'm going to look up what a regular octagon with side 6 length area would be. So what is the area of a regular octagon with side 6? Right? And 173.82, or we rounded, so 174. Okay? So that answer is correct. All right. So let's go ahead and jump into 10. Once you do a lot of these, you'll sit there and get the groove of it. All right. I'm going to go ahead and erase this. Again, if you want to sit there and see that again, just rewind. Let's go ahead and do, I said we were going to do number 10 next. Yeah, number 10 looks good. Okay, let's do 10. So this time we're looking at a decagon. A decagon is 12 sides. Okay, 12 sides. Took me forever to write that. So decagon with radius 20. Okay, so that means we're going to set up our right angle or our right triangle a little bit differently. So like I said, how I like to approach these, I set up my right triangle. Okay. Mark my 90-degree angle. I know I'm going to have 12 sides. I know my radius. My radius is going to be right here, because if I think of this as my center of my regular polygon, and then I go and I touch the edge, that's going to be my radius. So I'll mark this as 20. We're going to sit there and find this angle in a second. Opposite of my angle is my op side. Remember, opposite of my right angle is my height. Okay. Annotating always saves your life. And then the side that I don't remember is going to be my adjacent. Or that I don't remember. The side that I don't annotate, the one left over, is going to be my adjacent. Okay. So let's go ahead and find our angle first, all right? That we're going to use for our trig function. So how we find our angle is we do 360 divided by how many sides we have. So this is 360 divided by 12. Okay. 360 divided by 12, that's going to go ahead and give me 36. No, what did I do by 12? Sorry, I forgot my calculator. 30 over 2. Oh, it's going to be 30. Sorry. And then remember, I have to divide this by 2, right? Because right now I'm accounting for a whole triangle, right? I don't want my whole triangle. I want the triangle I created with my apothem, my right triangle, right? So I have to divide this by 2 to find this angle right here. When I divide that by 2, I'm going to get 15. Okay, so 15 is the angle that I'm going to be using when I sit there and plug in my trig functions and everything. So 15 degrees. Cool. Right? So again, remember, I have to sit there and find my base and height to plug in to this formula at the very end. Once I find them, my base is my parameter. My height is going to be my apothem. So let's start by finding our parameter. I'm just going to put P for parameters, right? So we can start by doing that. Notice they didn't give us our side, all right? So we're going to have to sit there and use trig to find our parameter. All right. So to do that, I notice I have a hype and I want to find my op. So I'm dealing with something that has hype and op. Most likely, I go up to my chart. I see that sine deals with hype and op. So I'm going to use sine. Okay. So I do sine. And then of my angle that I just found, 15 degrees. 15. And that's going to equal, what is it again? I always forget. Op over hype. My op, I don't know what it is. Just for a second, I'm going to erase this. Like I said, my op, I don't know what it is. My hype, I know what it is. That's my radius. It's 20. I use regular algebra to sit there and solve for this. I multiply both sides by 20. That cancels out. I get x equals sine of 15 degrees. Oops, I forgot the 20. Because we're multiplying that 20 by the sine of 15 degrees. So 20, and then sine 15 degrees. And I just got that from multiplying both sides by 20. Okay. Now we're not done yet because all that found was this part right here. Okay. That just found the part of my right triangle. But if I want to sit there and know my whole parameter of my whole regular decagon, all right, then I need to sit there and account for this side as well as my whole triangle, right? Because that whole triangle is going to account for my whole one side of my decagon, okay? So that means I need to take what I found here and multiply it by 2, okay? That's just reminding me I got to multiply that by 2. But wait, that just gives me the whole side of this whole triangle. I want the whole perimeter of my whole decagon, right? So that means I'm going to have to take this side and I have to add that as many times as my decagon, right? So this side, so I would have to do this side plus this side plus this side 12 times. Or I can just multiply this whole thing by 12, okay? And that's going to give me my whole perimeter. Again, if you did not understand why I multiplied by 12 and then by 2 and then by 12, go back and look at my other video and sit there and see how we have to sit there and use the parameter, okay? All right, so next, that goes for a perimeter. Now we have to find our apothem. Our apothem is just our adjacent side right here, which is like our height. So let's go ahead and find it. I want to use usually what they gave me. They gave me my height and my adjacent. So I need to use something that sits there and use height and adjacent. That's going to be my cosine right here. Okay. So let's go ahead and use cosine. So I'm going to have cos of my degree, cos of 15. And that's going to equal, I always try to say SOHCAHTOA in my brain, but adjacent over height, right? So that's just going to be x over 20. Okay. Now I want to sit there and solve, use algebra. I multiply both sides by 20. The 20s cancel out right here. I'm going to go ahead and write this because I always like writing my variable on the left-hand side. X equals 20 cos 15. Okay, and that's my apothem right there. Boom. That's going to be what this is, my height of this right triangle is. Right? Now that I have my parameter and now that I have my apothem, I can go ahead and plug it into my main formula to find my area. Like I said, if you are on a test, before you sit there and start chugging away in your calculator, I would write down everything you have and then plug it in your calculator. So if you do make a calculator error, your teacher already knows that it was a calculator error and not a mathematical error. So I would do 1/2. And our perimeter, we have a long perimeter this time, so it's going to be 20. sine of 15. And then we multiply that whole thing times 2. And then we multiply that whole thing times 12. 12. Okay. All right. And then we multiply this whole thing. Sorry, I'm running out of room, so I'm going to go down here. Then we multiply this whole thing by 20 cosine of 15. I always like to put extra parentheses because I like to section everything off and make it neat and clean. Okay. You don't have to if you don't want to. All right, so that's my answer right there. Now I'm going to go ahead and plug this into my calculator and see what we get. All right, so let's go ahead and do the calculator work. Let's clear this. So I'm first going to get 1/2 times, I'm going to put this in parentheses, 20. And then I have 15, 20 times, I'll do 15 sine in parentheses times 2 times 12. All right. Times, I'm going to put this in parentheses just to be safe, 20 times 15 cos. Okay. That's going to be equal to, oh, interesting. I get it's equal to 1,200 cm squared. Right. And again, I'll check my answers just so you guys believe I am the true mathematician that I am. All right. I believe this is the right answer. That looks about right. And that's cm squared. Okay. All right, so let me go ahead and show you guys the answer. Decagon with radius 20. Let's go to our good friend Google. The area of a regular decagon with radius 20. Usually they just sit there and pop up on Google and give it to us, but let's see if we get, what's the area of a regular decagon? Let me see, make sure I spelled that wrong. Decagon. There we go. Okay, so the area is 1,200 square cm. So that is correct, guys. And we're doing good, right? So let's go ahead and do 7. I'm probably going to blow a little bit faster through these because I don't want this video to be like an hour long. So for 7, I'm going to move a little bit faster. All right, so 7, we have a decagon with side length 4, with side length 4 yards. All right, so a decagon is going to be 10 sides. First thing I'm going to do is I'm going to create my triangle, my right triangle, right? For this one, right off the bat, I'm going to go ahead and just find my side. I know, or my angle. I know I'm going to have to do that. So that's 360 divided by 10, which is just going to give me 36. But remember, I have to divide that by 2 because I'm trying to find the angle for my right triangle, not the whole triangle. And then that's going to give me 18. So 18 is going to be the degree that I'm using when I sit there and plug into my trig functions, right? Just to label my stuff, I have this as my op. My op is always the opposite side from the angle that I found. my height is always opposite side from my 90-degree angle. And then your leftover one is your adjacent. That's what we're going to find when we find our apothem. What other information do they give us? They give us our side length. So remember when they give us our side length, that's the side length of the whole triangle of that we create inside a regular polygon. I just want the one for the right triangle. So I have to divide that 4 by 2, and that's going to give me 2 for this side. All right. And so let's start off by finding our parameter. Our parameter is going to be way easier to find this time because they gave us our side. Our side is 4. So then to find a parameter of our regular polygon, I just do the number of sides times the length of my side times the number of sides. Number of sides, it's a decagon, so that's going to be 10. Our parameter in this case is going to be 40. I love when they give you easy parameters like that one. So 40 we're going to use to plug in for our B. And again, now we find our apothem. Kind of see how the steps are going. These are like the 2 main steps. To find our apothem, we're going to sit there and use trig. They give us our op, but we're trying to find our adjacent. So I want to use one of my trig functions that use op and adjacent. That's going to be tan. So I do tan of the angle that I found. That's going to be tan of 18. Equals 2 over x, because op over adjacent. Yep, op over adjacent. I solve this using algebra. I multiply both sides by x. I get x tan equals 18. Divide by tan in parentheses 18. So then again, sorry, I'm going fast. If you don't understand it, leave something in the comments. Just using algebra, I multiplied both sides by that. So 2, and then I divided, once I got the x over there, tan of 18. Okay. Okay, so that's going to be my apothem. So now I have my apothem and my parameter. I just plug it into my area formula. So I'm just going to do A equals 1/2. A equals 1/2. My parameter is 40. And then my apothem, which is 2 tan of 18. 18. Okay. That's it. For sake of time, when you do your calculator work, this should come out to be, let me do this on my phone really quick. This should come out to be 123 centimeters squared. And that's calculator work. cm squared. Okay. And that is 100% correct. I'm 100% sure. All right. So let's do 11, and then I'll try to get to the bottom ones as well. Actually, 11. I'm going to skip 11 just for sake of time. I think you guys did. I think those 3 are pretty good. Okay. If you guys want to see anything from 6 through 13, again, leave it in the comments. More than happy to sit there and go step by step on what I'm doing. Okay. So for 14 through 19, I'm only going to do one of these. I'll do 2. I'll do 14 and 15. Sounds good. Okay, so this one, we're finding the area of each triangle. Round your answer to the nearest 10th. This comes from the theorem that we have in 10-5. It comes from the area of a triangle SAS theorem. Or the theorem is 10-8, I believe it's called. Okay, but look in my past video and I go over that theorem. Okay, so let's go ahead and find the area for 14. So since they already proved us for us mathematically that we can use this theorem, that theorem was 1/2. I'll write it up here just so we know. BC, which are my sides. And then I take the sine of my included angle. Okay, my included angle is the angle that's in between my sides. Okay, 57. Okay. Or, sorry, this is supposed to be the formula. My included angle. Theta. Okay. Or they called it A. My apologies. That's what they called it, A. So let's go ahead and do 13 really quickly. I'm just going to set up our 14. So I'm going to do A equals 1/2. My B is 11. Okay. And it doesn't matter which side I pick first. Okay. Multiplication is commutative, so it doesn't matter. Okay. So 11 and 6. And then I'm multiplying this by my included angle. Okay. My included angle is 57 right here. 7 degrees. Okay. All right. If you put this in your calculator, again, it's all multiplication with this one, so it shouldn't be that hard to put this one in your calculator. The answer you will get, I didn't write down the answer, so let me put it in my calculator. The answer you'll get is 1/2 times 11 times 6 times 57 sine. No, we'll do 28, 27.6, but we'll do 28. 28 cm squared. Okay. That's the answer for that one. That's not that bad. 15, I'll just set it up that it's going to be the same with 15. The only thing is that you're dealing with mixed numbers. Remember, with mixed numbers, you can sit there and write them as improper fractions. Improper fractions are fractions where the top number is bigger than the bottom number. Okay, so let's go ahead and do that. Again, I'm using the same formula. A equals 1/2. My side 12. I can change this mixed number into an improper fraction. So that's going to be, I multiply 5 times 2, 5, 10, and then add the 1, 11. So that's 11 over 2. And then times the sine of 33. Sine 33 degrees. And you can go ahead and type that in your calculator and sit there and get your answer for 15. Okay. Any questions on 14 through 19? Just leave a comment. Let's quickly finish up with number 20. For number 20, they want us to sit there and find A through F for the given figure over here. So let's quickly go through this one. This one, they want to find the measure of POQ. So that's this angle right here. Remember, we can find that angle. We do 360. OQ. No, my apologies. They want us to find POQ. So they want us to find that whole angle. Remember, to find that whole angle is just 360 divided by the number of sides we have. This is a pentagon, so divided by 5. Right? So that answer is just going to be 72 degrees. Okay. For B, they want us to find OX. Oh, no, for B, they want us to find POX. So that's the smaller angle. So since we're finding this smaller angle now, when we create that 90-degree triangle, all we're doing is dividing that 72 by 2, right? We're splitting that angle in half. So that's just 72 divided by 2. And that's just going to give us 36. 36. Right. Moving right along. They want us to find OX. OX, that's my apothem. Remember to find my apothem. I want to sit there and use trig. For this, just as a visual, I'll draw that same right triangle right here. This is my height. This is my op. This is my adjacent, right? That's the angle that we found in B. So that's 36 degrees. All right. And did they give us any side lengths yet? They gave us our radius is 10 right here, so we can use that. Remember, my radius is going to be my hypotenuse. Okay. So let's go ahead and find our apothem, which is our adjacent side. I'm giving my hype, so I want to sit there and use something with hype and adjacent. Hype and adjacent is going to be my cosine. So I can sit there and use cosine of the angle I found, which is 36, equals x over 10. Remember, multiply both sides by 10. You're just going to get x equals 10 times cosine of 36. When you, let's just leave it as that, and then you can plug that in your calculator. So x equals, or this can, we can say our apothem equals that. Equals 10 cosine of 36. Plug that in your calculator. That will give you your apothem. For PQ is going to be our side, our whole side, right? So to find our whole side, first of all, we need to find our op. All right, so we're going to have to sit there and use trig for this one too, because we want to find this. So that's going to be, I want something with hype and op. That's going to be sine. So sine of my angle, this is for D, sine of 36 equals x over 10, because op over height. So then I get x equals 10 sine of 36. But remember, that doesn't give me everything. They want my whole side right here. They want all of PQ. So I have to multiply, because right now I just found this, okay? But I need to find my whole side, so I need to multiply this by 2. And that will find my whole side of PQ, okay? So for this one, that's D. And so F, find the area. F, find the area. For this one, I'll set it up because we already found everything, right? So our area, remember, is 1/2 our perimeter. Our perimeter right here is just going to be D, whatever. I'm just going to put all this from D. It's going to be D times 5, right? Because we want to find our perimeter. The Z is just one side. And how many sides we have? 5. All right, D times 5. And then our height, which is our apothem. This is our apothem right here. So it's 10 cos 36. And when I say D right there, I'm just trying to save time by not writing as much. I don't mean the variable D. I mean what we found here, D, okay? So if you sit there and plug that in your calculator, you go ahead, you'll be able to find F. All right, sorry the video was so long, but we got a lot of good work done. If you want to see any of the other problems that I did not do in another video, like I said, just leave a comment. I will respond back as soon as I can and show you step-by-step work of anything that you have questions on. Okay, so please subscribe or leave a message, and hope you guys are doing good in math. Thanks.